What an absolute treat to be able to work on this museum piece. The 20-ish year old BVM F-100, completely done in flight metal. If you missed the first video, we did the gutting of the aircraft. So we took all the old stuff out of the aircraft and we are now starting the rebuild process. I think this is going to be a little bit scattered, but we're going to ultimately get this plane done, get it refit with all brand new equipment, new turbine, go over everything, make it airworthy. It's going to be a fun project. I'm looking forward to this thing. This is a beautiful aircraft, guys. I encourage you, there's some links in every video to the playlists for these aircraft. So if you missed the first video, click that link for the playlist down in the video description, and that will take you to the playlist which has all of the videos in the series. Of course, there's only one previous to this one, which was the gutting of the aircraft. So, like normal, we are going to start with taking a look at our equipment that's going in the aircraft. Pretty simple layout, nothing overly different than we've done before. And we'll talk about some of the stuff that's going in the aircraft. And like I mentioned, this is going to be a little bit scattered because when you're dealing with an older aircraft like this, in my opinion, everything needs to be taken out, looked at, and put back together. Something like this plane, it's been sitting in an office on a desk for a long time. I don't know the actual length of time, but a long time. And it needs some TLC. It needs to make sure that it's 100% to make it airworthy. And that's the goal of this project. But I think it's time to get the apron back in use. Apron, smock, whatever you want to call it. And yeah, so we've got the apron back on. We're getting serious. We're getting ready to work on this aircraft. So let's take a look at some of the initial things that we probably need to do to move forward. All right, so as I mentioned, we gutted the aircraft in the last video. Pretty much got everything out, but there's still some things here and there. Obviously the servos are still installed. We've got a bunch of our miscellaneous stuff still floating around in there, but a lot of that stuff came out. So I'm thinking the first thing I'm going to do is we're going to split this fuselage and we're going to start with the back end. That's normally what we would do with an aircraft like this, but the primary reason for that is there's a little bit of damage on this thing. It's been like this for a long time. So if you look at the leading edge, you can see that it needs to have some TLC done to it. Now obviously with the flight metal, I've never worked with this stuff, but there's really no fixing it. So what I'm thinking about doing is we can, in an area like this, rather than just leaving it to look ugly, we can patch in an area, and we could even go one step further and put some scale rivets to make it look like there was a patch done. But we do ultimately have to get the horizontal stab on this side structurally sound. I can actually feel that if we're looking at the underside here, this panel line right there is separated from the leading edge. So we do have some structure work to do. Getting this airworthy is the first concern. Getting it looking good is the second concern. So what I'm thinking about doing is we're going to separate that back end and we are going to probably take the stabs right off. That will allow us to take a look at everything, inspect everything, check our fasteners and everything. That's super important. So I'm going to be learning as we go through this, but of course it involves taking apart all of the fastener stuff in the back of the aircraft. So fortunately, separating this aircraft is fairly simple. There's 4 bolts holding it all together. We did have it apart to take the pipe out and everything, so that is going to be coming out. So we'll get back to this. We're going to take a look at the equipment that's coming out of the aircraft. So let's begin with that. So the first thing, and probably the one thing that everybody always wants to know first, is what's the power plant? Well, we are installing a Chikoi 240 engine in this aircraft, and this is the engine. So beautiful, beautiful engine going in here. And yeah, just great. So the 240 that's going in here, it's the new Pro version. So it's got the Pro hub. We did a video on this and the features of it and stuff. So But that's the power plant. Now, if you look at the power plant that came out of here, it is an old AMT. I think this is an Olympus engine. This is the control module for it. There we go. So 2005 compatible. I don't know what the model is, but anyways, that's what came out of there. The size difference is astronomical. I think when we did the unboxing or the decommissioning video, I think this engine was multiple pounds lighter than the engine that's going in there. Now, I did put a guess out there of our final weight. I can't remember what it was. I'll have to watch the video, but I think I said 38 pounds, I believe. I have to look it up. Anyways, I'll look it up and I will return and report on this video as well. So this engine is available. It comes with what you see here in the box. So there's no data screen, there's no engine straps, but this is what it will come with. There's fuel pump, there's all those types of things. So if you are an AMT fan and you're interested in this engine, please reach out to me. Emails down below. And obviously we're not giving this thing away, but it will be, it is available. I think it might have a couple flights on it. I don't know. It's very low time. It was put in this aircraft and really never flown. So anyways, that is available if you're interested. All right, and we do have a giveaway in this video for you guys. And this video comes from Joe at RC Custom 3D Printing. Joe does much of our stuff that we have on our website. So we order it from Joe. We stock it here in the shop. You guys order it from me, and I fulfill those orders, and everybody's happy. So I love the work that Joe does, and this is kind of a cool kit that he's put together. So this is the basic turbine install kit. So I'll open this up, we'll take a look at it. But if you want to win this, we'll ship it to you for free. If you want to win this, you have to comment with the word AMT, as in AMT engines, AMT down below. So make a comment using the word AMT and you'll be entered to win this turbine install pack. Let's open this up and take a look at it. All right, so this stuff is great. Love this stuff. So we've got a battery holder. This is the quick release version. So these things are wonderful. You basically can strap your batteries into the tray, and tray comes in and out. All these parts are printed in PETG carbon fiber. So we've got the battery holder. We've got some 6mm line holders, 8mm line holders. We've got some battery, XT60 battery clips. So this is the screw angled mount, screw flush mount, glue in angle mount, glue in flush mount. We've got a valve holder. These things have been my #1 seller on the website. Love those things. And then of course a UAT holder. So great little install kit, works wonderful, has a bunch of parts in there. This is my most used and purchased parts on the website. So thank you, Joe at RC Custom 3D Printing, for supplying that kit for giveaways. We're gonna have a lot of cool giveaways coming up, guys, over the winter build season. So lots of different suppliers are reaching out to me and saying, hey, can we feature some products? Can we give you some products to test? And giveaway products as well too. So lots of cool stuff coming. So thank you, Joe. Don't forget to enter. You've got to be #1, a subscriber. #2, you got to give this video a thumbs up. So down below, there's a thumbs up icon. Hit the thumbs up. And you also have to make a comment. The winner will be chosen randomly from the comments. You have to use the word AMT in your comment. Be creative, because I love reading them. All right, so we've got our parts laid out on the table here, just a random table, and we'll take a look at some of the stuff. Now, this is kind of a bit of a mix mash of old things, new things. We've got a bunch of things in here that we aren't even using, but we've just got everything laid out on the table. So we've got 747 servos. We've also got the R version. The R version, I think, is for the chute mechanisms. The 747s we have for, I think the leading edge is what they're for. We've got MKS 9930s. That's pretty much the staple we're using everywhere on this plane. So MKS servos throughout. Of course, Cortex, Pro gyro. Everything in this plane will be run through the Central Box 210. Now the reason we're going with the Central Box 210, this is a sort of complicated plane, but space is a huge premium in this aircraft, so we need to be very careful with space. That's key. Really, all of this space here is not usable, so we've got to fit everything underneath the intakes and on the side of the intake. So we'll get more into that as we get into the aircraft. Receiver-wise, we're going with two Rec 7 with the 40 centimeter dipole antennas, so that's our receivers. We've got an M-speed sensor that's going to go in the aircraft. We've got one of the really small switches, which is going to be the on-off switch for the aircraft. We've got a V-Speak onboard compressor. That is also going to be installed in the aircraft. We're going to be reducing our air tanks, of course, because of that. So we'll probably go with one of these larger air tanks, and that's it. We've got a Chikoi fail-safe sequencer. This is kind of something that we always use here at the shop. Great unit. Telemetry jives perfectly with Jetty. We've got a bunch of Chikoi valves that are going to be used in here. I believe this is what we're using. So we've got some two-way valves, one-way valves. So we need to take a look at our valve situation and see if we've got everything that we need. But that's probably what we're going to be using in here. And underneath that, we've got a Unilite kit. So the Unilite kit is going to be beautiful on this aircraft. On the aircraft itself, there's really, as far as I've seen, only two working lights. So the bottom lights that drop down. The rest of the lights appear to be like dummy lights. So like this one here doesn't actually do anything. I don't think this one in the back does anything. So we're going to be changing out various lights throughout the aircraft to get some cool effects on there. But the belly drop-down lights are really something that is critical on this aircraft because that is a key piece. We did order a set of Revic wing bags as well too. So the Revic wing bags for this aircraft, we did go with the kind of the custom line. And the reason we went with the custom line is this aircraft has the pylons all over top of the wing, or the underside of the wing. So it's got a bunch of details on the underside of the wing. We've got detail on the top side of the wing. So what Revic does with the custom line is they send you a set of mesh bags, or a mesh bag. So they sent me a mesh bag. We took the wings, installed it in the mesh bag, and I sent them back pictures so they could make any adjustments, and that goes into production now. So we've got those on order. They will be hopefully coming before the aircraft's done. But anyways, we are a Revic dealer here, so if you do need some or want some Revic bags, reach out to us. You can also go to them directly, but sometimes dealing with us is maybe a little bit more convenient because we're generally in the same time zone as most people, but and also we get a little bit of kickback with the purchase of the Revic bags. And of course, kind of goes without saying, but we are fortunate to have two Jetty radios here in the shop now. So our old DS24, I say old, but our G1 DS24 is now our shop radio. The new DS24 G2 that I have is my own personal radio. So love that scenario because all the aircraft can be set up on this radio now. This radio gets use in the shop, and that's takes away from using my personal radio and having just lots of extra time put on it. So, but this aircraft will be piloted with a Jetty DS24. The owner's got a G2 as well. So, but that's how we'll be setting everything up with. All right, so got the, just took the duct out and the canopy. And if you guys did not see, if you're just joining us on this video series, I really encourage you to go check out the first video where we dismantled this thing. It is bonkers to see how much equipment we took out of this. And it's going to be such a simplified setup going back in the aircraft. But basically all of our underside here was littered with wires and mechanical air valves, and it was just it was crazy. So here's sort of the mechanical valves that were in here before. So you've got a BVM smooth stop, you've got a BVM air valve, you've got a Robart air valve, another Robart air valve. Yeah, pretty wild stuff. So I think this is brakes, obviously. This one's doors, this one's gear, and this one's probably air brake is what it's for. So yeah, pretty wild stuff. So this gives you a shot in the aircraft of kind of how things are looking now. So previously there was a lot of the turbine equipment back here, turbine battery was buried back here, fuel pump, just a ton of stuff, and then just littered with stuff as you went in the front. So as it sits right now, I've been doing some thinking about this aircraft, and I think some of the basic things we're gonna do is we're gonna do compressor in this area, air tank in this area. I'm thinking we wanna try and make the air brake into a servo operated setup, so we'll see, rather than the air system. That's one of my goals. Yeah, obviously our lights previously, they dropped down with air cylinders as well. So again, that was all part of the mixing, right? So the air brake went down or something like that. That would actuate a valve, which would make these guys come down. Just crazy how much mechanical work was done on this plane previously. So there's still a lot of stuff to strip out of here. And step number one, like always, even though this really isn't step number one because we've done a bunch of steps already, but first thing we need to do is we need to get a new model set up in our radio. The reason we need to do that now is that allows us the ability to get servos set up as we work through this. Also gives us a starting point in my brain to kind of get things starting to lay out. So it's just a thing that I need to do to get this thing going. Because when we take that rear end apart and separate it and get the stabs fixed up and the rudder fixed up and the chute and everything fixed up, we need to be able to plug those servos in and program them. So I'm gonna get our devices updated, get a new model made in the radio, and that's the first step. So I was doing a little bit of planning on this aircraft, and I kind of underestimated how many functions we will need. So started adding things on to the program yesterday after getting the initial setup done. And even if we use 2 micro matches from Powerbox, so these would be used for our leading edge servos, we still have 20 ports or 20 functions needed. So that's with pairing up the 4 leading edge slat servos. So what that means is our initial plan for the Central Box 200 series is not going to work. Now we do have things like the, what is it called? SE6 switch from Elite, and the benefit of those, not switch, port plug system. Benefit of that is you can plug it into a channel and you can get 6 programmable channels on that device, 5 or 6. But the downside is you don't want to be plugging a bunch of high-powered things into that device. So in this scenario here, it doesn't really help us a ton because we still need a bunch of channels. We would have entire air systems and everything run off of it. So anyways, just easier to do the 300 series. So we'll be getting a Central Box 310. The other benefit of that is, well, it just makes things different, is we can use 3 3-cell LiPo batteries. So the same one for the turbine, same one for each of the power for the receiver system. And because they're going through the 300 series Central Box, we can regulate that down to 8.4 volts. Now we've got some things to consider. Number one, we've got an onboard compressor we need to power, so we could power that from the turbine battery. We could also power it from one of the receiver batteries. So we've got that option as well too. In the past, we've powered them from the turbine battery and it's worked beautiful. So we'll probably do that. All right, so we've also got our lighting system to power as well too. So we've got a couple options with the lighting system. We could, number one, put the little capacitor in each of the lights and run the lights at 3-cell LiPo straight off a battery, so that's a possibility. The other possibility is on the Unilight systems. I have run them off of a central box port before. So that central box port powers the lighting system, and that works very well as well. So there's a couple different options with that. We'll have to see how things jive because we've got 2 of the drop-down servos in this kit. That's something we need to be mindful of. And if we're powering or running those servos from the controller, then we may need to provide it with 2-cell LiPo voltage, 8 volts instead of the 12 volts. So always things to consider. But anyways, at the end of the day, we need a central box 310. We're gonna have to jam that in there somewhere. We'll be able to find room, but that's the change that we need to make. And I apologize in advance, guys. We've done a lot of talking in this video, not a lot of doing, but there's just, this plane requires so much planning. So I just took the intake duct here, put that back in, realized, oh yeah, I've got to put my tanks in here. So just looking at the amount of space I thought I had, we don't have. So crazy. Yeah, basically we're going to be pretty tight on space for sure. With that change to the 300 series central box, I'm just thinking about what needs to go in here. So, you know, if we're changing the air brake to a servo operation, we may need to mount a servo right here. That eliminates a bit of our space here. So I think on a plane like this, we are gonna have stuff kind of positioned, honestly, wherever it fits. I'm thinking we pretty much need to put our control systems in this area here and this area here. That's really the only free space. We've got this area beside the gear, of course, as well. Maybe air valves go here. We might need to put some of our air system up front underneath the ducting too. So lots of it is going to be spread out all over the place. It's going to be interesting, that is for sure. So, I'm going to separate the fuselage pieces here as the next step. And that's fairly straightforward. It's nice, simple to access Allen keys. It's a 3/32 size. And once those are undone, the back piece is gonna separate from the front piece. So we're just gonna get our other stuff moved out of the way. One thing I'm doing before I work on this plane is I am washing my hands. That may sound a little bit ridiculous, but with the flight metal, I don't wanna have any oil or anything like that on my hands. I'm gonna leave these top ones done up. We'll undo the bottom ones. There goes the tank. Okay, so now with the bottom ones undone, we can loosen this top guy and pull it off. Well, she's definitely an accurate fit, that is for sure. Okay, so we've got our 4 carbon rods holding the back end together. There's the chute. All right, so that opens up access a little bit back here, of course. So this allows us to get a lot of this stuff cleaned up, right? So this is where we are going to start removing Velcro, removing trays, removing clip holders, all the stuff that we will be not using or reinstalling our own stuff in the right locations. So I think the first thing I want to do, as I've talked about, is get those horizontal stabs undone and separatable, or at least the one that's damaged, so we can work on it easier. So to make things a little bit more accessible, be able to flip the plane upside down, we've put the main fuselage on the Lukey stand, so I think that may be where we leave it for the duration, at least right now. Taking the vertical stab off, and we now have the tail section sitting by itself. Also pulled the chute off as well. So with this underside view, you get a bit of a better idea of what's going on with some of the damage we need to fix here. Also the chute system. So there's a rod that comes down here, splits off into 2. The little pins hold this guy closed like that. The cable comes out the back here and just goes to the front or to the top section, which is the metal wire right here. So when this is flying, it looks basically like that. And then the chute unit here is spring loaded. So that's the reason for the larger size right there. So basically that flap is spring loaded into that location. So when this opens up, obviously the spring is what drops or pushes that out. And then here is sort of the tail hook setup which is also servo activated. So on the underside here, you can see some of the damage a little bit better. This horizontal stab, the right one's pretty good. We've got a little bit of flight metal damage right there, but the left one, we've got, I think this looks just like it is only cosmetic in this area. And this is our actual damage right here. Looks like there's impact damage. So this is what we actually need to fix structurally right there. So with that, I think we're just going to take both of these guys off just to make sure that we're satisfied. All right, so we want to get this, this repair moving and gluing as a first step, just so we're not waiting on it while we're trying to do other stuff. That noise you hear in the background is me testing some servos. So this is the top side. So when we fix this, we're going to do the structure first, and then we'll deal with the cosmetics after. Now we can add like a patch on the flight metal, you know, add a couple rivets, make it look like it was patched in. So that area is pretty straightforward. This area here, I would like to get that fixed because it's a fairly large chunk. You can see where whatever contacted this thing kind of hit it here and dug into the flight metal. That's not so bad right there. So we're probably going to add a patch to this area. And again, when we do the patches, we can just add our rivet details around the patch and it'll look like it belongs there, I think anyways. And the underside, so this is where most of the structure needs to be fixed from. So you can see there the leading edge is separated from the wing. So we do need to get aero epoxy installed in here. So we'll be delicate with it, but we kind of need to get it to about this location right there, which is where the actual rub mark on the leading edge comes all the way to here. So, but I can see it's opened up right to this location right there. So again, patching this isn't so bad with a piece of aluminum tape or flight metal. This stuff on the underside here, obviously we could just leave this, but we're here, we're doing these patches, we might as well fix these things up. So again, we'll do the same thing, probably just add a patch in here, put some rivet details around it, and same thing there, just to make it look good, like it belongs and like it was fixed properly. So anyways, so that is what we're gonna do first. Yeah, so I'm gonna mix up a little bit of high sol, do a little bit of examining here, and I think that should be fairly easy to get the high sol in there with trusty bent screwdriver's help. So we'll just, yeah, it's not so bad. You kind of have to go through the flight metal here until it stops moving. That's a key. So yeah, we're to rate this location right there. And when I'm dealing with stuff like this, I mean, the first thing I'm worried about is the structural integrity. So that's what I'm worried about fixing first. And then we'll worry about the cosmetics afterwards, obviously being mindful and not just destroying the thing. But so we need to come from here to here as far as our aero epoxy goes. And once we get that aero epoxy in there, we'll probably do a little bit of clamping on that leading edge just to keep everything in line. And we can also take some pieces of wood, clamp them on there, and that'll help keep everything in line as well too. So I'll try and be as detailed with this as possible, guys, but that's the repair. All right, so the repair is pretty straightforward, I think. So I took some masking tape and just put it along that seam line right there. And then I took trusty bent screwdriver with some high sol and just kind of packed it into the leading edge, almost like I was packing bearings, if you're familiar with that. Cleaned that up, pulled the tape off, and then we needed to make sure we clamped everything together. Now initially, I had looked at possibly taking some big pieces of wood, clamping it on there on both sides. The downside with that, I think, is it wasn't localized enough to get this piece lined up properly. So the little clamps ended up being, I think, the best solution. When I angle this and look at it, it's all lined up perfectly. So that's done. We'll leave that to cure overnight, and then what we will do is we'll focus on the cosmetic stuff tomorrow once that's all cured. So We'll get back to that. So moving back to the tail section, I'm going to start cleaning up the back end. And once the back end's cleaned up, meaning all of our tin foil and random pieces that we don't need in the back end are removed, then we'll look at doing our servos. All right, let's talk about full bypass systems here first, before we start getting into any of the detail work in the back end. So you'll find on older aircraft, like these BVMs and even some of the newer fully bypassed setups, one of the downsides with fully bypassed setups, this is the pipe, obviously this is the bypass, that's the exhaust pipe, engine sits in there. So air that comes in the front, it's all ducted from the front of the aircraft to the turbine. So air in equals air out. Now a fully bypassed system is extremely efficient. Now the downside with a fully bypassed system is the cooling, which is why this aircraft had a crap load of ceramic blanket all stuffed in the back of the aircraft. Now, the way we see aircraft design now, most of the aircraft we fly, is this is a very typical pipe setup for what we would normally see on today's aircraft. So you've got an outside layer pipe, you've got a, I don't know, half-inch space between the inner and outer wall of the pipe. You've got the hot end or exhaust end of the pipe, and the inner pipe is inset a little bit, maybe 1/4 inch from the outer pipe. The whole point of this is the inner pipe is creating what's called a Venturi effect. That is pulling air in between the outer pipe and inner pipe. So that's where the bypass comes in. If you don't have cheater holes built in to the aircraft, you are going to find that this is going to get hot and the back end of the aircraft is going to get hot, and you need all of that ceramic, 10 pounds of ceramic blanket back there to stop the heat from being an issue. Now on this aircraft, it's definitely an issue because of the flight metal. You don't want the glue to soften up. So heat is definitely a concern versus a painted finish. But if we do this properly, we're not going to have an issue. Now, I've noticed on this aircraft, it's already got a cheater hole built in, and it's built into the perfect location. So when this pipe's installed in the back end, you basically have the end that butts up to the bypass is sitting right about this location right here. So just rearward of the fuse joint. Now, whoever built this aircraft, I don't know if they did this on purpose, if it was part of the instructions or what, but there is a intake duct right here, which is going to allow air, and again, we're right in front of the joint. So that is a perfect location. As long as we keep that back end open and allow that Venturi effect to happen, we're going to get a ton of cooling air sucked in through that duct. Now that is a significant size right there, and that's going to allow a lot of air to be sucked in to that back end. Now, just to get technical, I think about CARF ultra flashes as an example. So one of the things on the ultra flashes is, this is not a good example, but it'll show you. In the ultra flashes, kind of in the back end, right about this area right here, you would install some NACA inlets, so just some triangle shaped inlets. And those two little inlets, which were like 1/2 inch wide, 1 inch long, that was enough air into the ultra flash aircraft to keep the back end perfectly cool. And without those inlets, because the original ultra flash was a fully bypassed system, again, there was very little air being sucked in to the fuselage. So there was a nose door and all that stuff. So it was definitely an interesting scenario, and it's a great solution on this aircraft to just use the more modern system. Now, when we put this together, we are still going to put some ceramic blanket in certain areas because we can't get away from how this aircraft was designed. So our pipe sits in here. Obviously, it's nice and centered in this area, but we've got our tail hook servo sitting right here. the pipe's pretty close to that, so we're going to make sure we reinstall this little piece of ceramic blanket over top of that. We've got our upper servo here for our vertical stab or rudder surface, and pipe sitting a reasonable amount away, but definitely would be a good idea to put a layer of protection across here. Now previously there was a piece of ceramic blanket siliconed in there. We may just redo that because that's a fine way to do it. All the surfaces from here going back, so the control surfaces and everything, that's all metal, so not really a concern with that. But we've also got our chute holder back there, and we're going to put a layer of ceramic blanket in that area as well too. But we're not going to take the 10 pounds of ceramic blanket and completely stuff it in there. Now, of course, we'll be testing things out. That's a critical thing that we need to do. So we're going to plan it my way, and when we do the first run on this aircraft, obviously we're going to be very attentive on the back end and making sure that it doesn't even get warm back there. If it starts to get warm, obviously we need to do something about that. But I suspect as long as we do this and we're mindful about it, things are going to work out just right. So just pulled the clamps off here, and that turned out gorgeous. That's a great repair. Turned out awesome. So it's nice and strong. There's no movement there anymore on the leading edge. Yeah, it's all good, all solid. So that's great. We'll come back to this in a second. So we want to get our servos prepared to go in the back end of this aircraft. And if you're just joining us on the channel here for the first time, we do something with all of our servos, and we cycle these servos, or burn the servos in is what I'll call them. We run this through 990 cycles. Every single servo we put in a plane gets that treatment. And the reason for that is it allows the servo, if it's going to fail during that burn-in process. So we have had some servos in the past, no MKS ones actually, but we've had some servos in the past that have failed during that process. And obviously you want that to happen not in the airplane, not on the first flights. So the theory behind that is, you know, if an electronic device is going to fail, it usually fails in the beginning part of its life. And that's why we want it to happen on the test bench. So I'll show you what we do to cycle these servos. All right, now there's nothing specifically unique about the Jetty box other than it works for servo cycling, for programming things, for lots of different things, and of course we use a Jetty radio. But if you don't even if you don't use Jetty, this is a very valuable device. So we plug a battery in, and we're going to plug our servo in. And basically the first screen that pops up here is impulse generator, which would be like servo centering as an example. So we're going to hit no. Servo cycle, we're going to hit yes, and we're going to go up arrow to 990. That's the max the device goes to. We'll hit OK. As soon as we hit OK, the servo is going to start cycling or moving. And we want to increase the movement to its max of 500, and we want to increase the velocity or speed to about 30. That's where I normally run them at. And this will, you can see it counting down there, it will cycle this servo 990 times back and forth, and that's how we burn in our servos. Most servos are good servos. They just get warm to the touch, they don't get hot, and they just go through the process. And that's basically what we do for all the servos. Takes, I don't know, 15-20 minutes per servo. You can put a Y cable in there if you want to. So one of the common questions that I get very often about this process is what happens if a servo fails? Well, brushless servos, usually they will seize in a stuck position, and the coreless servos and also sometimes brushless servos, they'll get so hot and they just kind of stop moving. So right now the servo is moving a fair bit like this. They'll just slow down and they'll basically just stop moving. And the brushless servos, if you have a horn on there, generally it's almost, I'm not going to say impossible, but with your hand it's very difficult to even move that servo. So that's what we're looking for, but yeah, this is the process. All right, so as this one finishes, I'll show you what the process is here. So what I do is I take these servos and I put a check mark on them so we know they're done. And this servo is, I mean, it's not even warm, which is awesome, because some servos, the cheap servos, the crappy servos, I've been testing some lately and they get so hot you can't even touch them. Okay, that's 3, 2, 1, and done. So it stays on the servo cycle thing, so we'll unplug this one. Take a servo we haven't tested yet. Plug that in. And all you have to do is it saves, as long as the battery stays plugged in, it saves all those settings. So we just hit yes, okay, and it's already set up with the previous servo's settings. So super simple, works great, very, very important step. This clip goes in the first video. All right, so touch-up time on the flight metal. So what I do is took some foil tape, cut a square. You have to peel off all the old stuff that's bumped up. Obviously you can still see the damage through there, but there's only so much we can do with that. So, so we've put the patch over top. I took my little rivet tool, which is just a small brass tube that matches up with the existing rivets, glued it into a piece of wood, and now we made our little rivet holes. So all I did was hold this down, rotate it around with light pressure, and that makes the rivets. Once that's done, took my steel wool and just roughened it up in the direction of the original panel roughing. So you can see these panels have their own direction to them. So the original guy that did this, you know, this panel is done side to side, this panel is done this direction. So we've also got a bit of goop on there that I noticed previously. So that's one of the ways to touch up the flight metal. So we're going to continue on and do our repairs elsewhere. I think that looks really good. It looks like it was repaired at the aircraft maintenance factory. And there is the patches on the underside of the horizontal stab. I think those turned out really nice. So we've got that one there, right there, there, and there. And yeah, I think the rivets, the patching looks good. Looks like it was basically, I don't know, just patching some damage. So now we'll do another one on the leading edge here because we've got a lot of it scraped off. So we'll get that one done, and then we'll do another small one here on the top. And that stab is, after that, basically completed. That's awesome. And there's our top side done. So we have our little patch here, leading edge patch, and that turns out beautiful. Obviously, when we scuff this with the steel wool, we do get a little bit of shininess exposed around there, but eventually the aluminum will weather and look all dull and weathered again, naturally. So awesome. Well, and if you've been following the video this long and you're still here, congratulations, and thank you for actually watching all of the video. Just a reminder, guys, this video we are doing the giveaway from RC Custom 3D Printing for the turbine install kit. Just a reminder to make a comment down below with the word AMT in it, and you'll be entered, or that's where the winner of this will be chosen from. You also need to be a channel subscriber, so hit that subscribe button down below if you're not already, and give the video a thumbs up. Those are the 3 requirements to be chosen to pick this turbine install kit. We will probably do the draw for this kit either in the next video or video number 3. We'll see how timing works out, because we have to give you guys some time to actually to make some comments. All right, and that is gonna wrap up video number, I guess, 2 in the series of the BVM F-100. We didn't get a lot accomplished in this video, I don't think, other than some planning work. That's really what we got a huge amount done. When I do a project like this, I really spend a lot of time planning, figuring things out. There's a lot of thought that needs to be put into an aircraft like this. The refits, you know, on a sports jet's pretty simple. On this guy, there's a lot of stuff going on in here that we need to make sure we do properly and do well, and hopefully better than the original. So that's why there's so much thought given to a project like this. Next video, we're gonna get into the servos and start actually putting some servos in and start moving forward with our refit of this aircraft. So lots to do in the next video. Thank you guys so much for watching. Just a reminder to check out the Lighter Side of RC After Dark. It's our completely separate channel. We do live streams here from the shop. We just hit 2,000 subscribers on that channel. I love it because every 2 weeks we do a live stream here from the shop, generally Saturday evenings. And the cool thing is, if you guys are on during the live stream, you get to interact with us here at the shop. Usually there's a few of us here and it's just fun. It's a blast. I love it. So encourage you guys to check that out. There's of course some links down below. Thanks guys for watching, and we'll see you in the next video.
We hope you enjoyed the video, so like
and subscribe.
See you in the next one.